Magnets can be created by running currents through wires, by finding a suitable material that naturally has all the magnetic fields of its atoms aligned, or by forcing the magnetic fields of atoms to align. But there's one more kind of magnetism that all materials exhibit, even those whose constituent atoms aren't magnetic, though it's so weak that the other kinds of magnetism often overwhelm it. Basically, an external magnetic field causes the electrons around atoms in a material to change course, and their new motion generates an opposing magnetic field. This field is pretty weak, but it does cause the material to be repulsed from the magnet a little bit. For example, if you hang a wooden toothpick in a magnetic field, the ends will repel the field and it'll end up aligning across the field. This is a convenient way to remember the name of this kind of magnetism, diamagnetism, since dia means across, like the diameter measured across a circle. Diamagnetic materials will repel a magnet, and a diamagnetic compass will point across the magnetic field. That is, it'll orient east-west. As weak as it is, diamagnetism is pretty darn awesome because it's a repulsive effect. Any diamagnetic material will levitate in a strong enough magnetic field, like this chunk of graphene, or since water is diamagnetic, this frog. In principle, humans could also be levitated this way, though the magnetic fields required would be enormous. There are also a lot of subtleties we've skated over, like the fact that nitrogen is diamagnetic even though as an atom it has unpaired electrons. One might think that it should at the very least be paramagnetic. But nitrogen atoms bond to form N2 molecules which have full outer electron shells, and are thus only diamagnetic. On the other hand, molecular O2, as we've seen, still has unpaired electrons, and it's paramagnetic. You've probably also seen how superconductors can levitate in a magnetic field, which is a kind of perfect diamagnetism. Not only do the currents in a superconductor create opposing magnetic fields, they expel magnetic fields from the material entirely. But the root cause is very, very different, and that's a journey for another day.